Hello guys, my name is Edson. Welcome to another STM32 tutorial, and today I'll be showing you how to configure the canvas and also send data via canvas. For demonstration, I'll be using two nuclear boards, and as you can see, and this is how I've connected my board. I'll be using pin D14 and D15, basically which maps to PB8 and PB9 for CAN TX and CAN RX. You notice that in CAN transmission, you find that TX is connected to TX and RX is connected to RX, hence the connection shown here. Again, I'll be using these two LEDs. You find that this wire is a common ground, which is connected to ground, and these other LED is connected to the same ground. And also I'll be using pin PA5 for this both boards to control the LED. So what I'll be doing, I'll program these two boards each at a time, and if we press this button, you shall send data through the canvas, which will turn on and off this LED, which is connected to the second board. And if we press this button from this board, you can control the LED, or you shall transmit data that will control the LED on the other board. So as you can see here, I'll be using pin again pin PB8 and PB9. So pin PA5 is D13, which is connected to my green LEDs for each board. Find that this is D13. So let's get started and go to CUBEMX and create a new project, and I'll select my board. So this is a nuclear, F446RA. So you select the board and start project. So you will not initialize the default mode, since we shall configure afresh. So as usual, I'm going to clear all the pinouts, and I'm going to activate to enable the crystal oscillators. That's the external, and I'll also be using I go to connectivity and configure the canvas, so you have to activate that. And I'm going to use in time counter in bit segment 1, I'm going to use 4, and in time counter bit segment 2, I'm going to use 2. From there, I'm going to enable the automatic bus of management, and I'm going also to enable the auto transmission. So then from here, I'll go to NVIC setting, and I'll enable all these interrupts. And as I said, I'll be using pin PA5 connected to the green LED. So I'm going to label this LED, and from there, since I'll be using PB8 and PB9, you can see that these are mapped to PA12. So I'm going to control then click on this and shift it to PB9, or simply you can you can click on PB8 and enable CAN RX. So you can see the mapped the pins are mapped onto pin PB9 and PB8 as shown here. So then from there, I'll go to system view, I'll go to GPIO, So for the LEDs, I'll enable the pull down resistor, and then I'll also go to system view, go to NVIC setting, and I'll see that I have enabled all the interrupts. So one remaining thing is pin PC13, which shall be pressing to control the LEDs on the other board. So I'm going to enable this pin as external interrupt, and I'm going to system view, then NVIC, then I'm going to, okay, let me go back. I'll go to GPIO, then PC13, and I'm going to configure these in interrupt mode with falling edge trigger detection. So then from there, go to NVIC and enable the interrupt for that pin, so that we can generate the function for the IRQ handler. So from there, I go to clock configuration, then I'll select the external oscillator, then I'll use 84 megahertz. So then from there, go to project manager, give my project a name, I'll call it CAN bus YouTube. Then I'll be using KEIL uVISION, so I select my toolchain as MDK arm. So from there, so it generates code now. Then after the project is generated successfully, you open project. Then from there, you go to application, user core main.c, and include several header files. So I should include stdio.h, I should include string.h, I should include stdlib.h. So, and then we first build the project. So the project is okay so far. So from there, I'll open, I'll go to functions, and then I look for this file called halcan.c, and this is a guide on how you can use this driver. So until here it is done for us, and also this is also done for us. Initialization of the CAN peripheral is done for us by CUBEMX. So what is left for us is from here, configuring the filter. So if I open where there is defined, so you'll find that Halcan config filter takes the handle type def and also the filter type def. So we are going to declare a variable of this type def of filter type def. So these will be in the variables. So I'll have CAN filter type def, and I'll call it scan filter. Then from there, something else I want to declare the headers, whereby we shall store the data frame, that is the can data frame. So can rx header, so I just call it rx header. So then I'll have can underscore tx header, and I'll call this just tx header. Then from there I'll have to declare a variable of uVISION32 mailbox, call it tx mailbox. Then I'll have to declare two variables, tx data, and I'll send only 1 byte. Then uint8 underscore t, then rx data, and I'll receive just 1 byte. Then we are good to go with those variables. Then we shall go and initialize the filter for the can. So this will be in mx can. So under user code begin can1. So I'll have dot activation. So this is a structure. If I go to where this is defined, you'll find the structure. So we shall initialize all these variables, and if we go to where this is defined, you will find that it takes, or the parameter can be of this value. So if we find that, you'll find that you can either disable or enable. So I'm going to enable the filter. Then I'll have scan, so just go quick through them. Filter bank, scan, FIFO assignment, scan dot id high, scan dot ld low, scan dot mask id high dot filter mask id low, dot mode dot scale dot filter bank. Is there any other variable? 1 2 3 4 5 6 7 8 9 10. So 1 2 3 4 5 6 7 8 9 10. So excuse me, so there's nothing else. So filter bank will be 0. Then FIFO assignment, if I go to where it's defined, it can be of these, can take this parameter. So I'm going to find that, and you find that we have can filter 540 and 541. So I'm going to use 540. Then in the filter id high, so maybe you can go to this, and you find that it can take data from 000 to 0FFF. So in the meantime, I want to keep them 00 or 00. So just copy paste this there. Yeah, there. Filter mode, so I go to mode, so can take this. So let's see. Filter mode can be filter mode ID mask or filter mode ID. So I'm going to use ID mask. Then filter scale. So let's see what this has. So can filter scale. So let's find this. So it can be either 32 or 16 bit. So I'm going to use 32 bit. And for slave start filter bank, I'll use 14. So, and if you are using 2, you can if you are using 2 can peripherals, you can make it 28. So from there, I want to set the TX header that we declared. TX header dot header dot maybe I can start with IDE. So these can be ID standard mode. So maybe you can, if I open where it is declared, you find that you can either use it in standard ID or extended ID. Then we have TX header dot the ID of the device. I'll have it to as 11. Then I'll have another TX header dot RTR. So if I come back here, let's see whether I have that definition. Okay, it is here. So it is can remote transmission request. So if I find these, if you see that you can either use it can RTR data or can RTR remote. So I'm going to use data. And then lastly, TX header dot DLC. This is the data length that we are sending. We are just sending 1 byte. So then from there, let's see whether everything is okay. That is okay. We initialize the filter, but now we did not configure the filter. So I'm going to use Hal can filter config. Okay, filter. So let me go back to can.C and look for that function. It is here, Hal can config filter. So if I open where it is defined, so I'll copy this, paste it there, and then this guy takes 2 parameters, the can type def, and then from there the structure. So this is scan filter. So and then we can test these if Hal config filter is equals to Hal underscore k. Okay, let's test if it is not. So there's an ampersand there. If it is not okay, then there could be an error, so we call the error handler. So if it is then configured, we are going to start our can peripheral can underscore start. So and takes one parameter, and we're also going to test this. If it is not equal to Hal, okay, then we want to call the, so this is Hal can start. Going to call the error handler 2. So there we are. We have configured the filters, we have configured the header for the data frame, current data frame. So then the remaining thing is to configure the callback or the LEDs function. So in if I go to can.h, can.c, you'll find that there are several functions which are defined to be used at your disposal, and one of the most important is this, the Hal can rx54 message padding callback. So I'm going to copy this just the way it is without the weak object, and I'll copy it in I'll paste it in user code begin 4, and then from there, this is the function that will be called when the RX or the microcontroller detects that there is a message coming in the RX540. So what we want to do after we detect that there is a message, or after this interrupt is fired, we are going to read the message. So for us to read the message, we shall use this function called get Hal can get message. So I'm going to copy this here, and it takes a few parameters to the type def handle, that is can1, and then this is for rx54. Maybe if you come here, okay, you'll find that rx54 number of the received message to be read. So this parameter can be of this value. So I'm going to copy this and find it here. You see that we have rx540 and 541, but in the filter configuration we decided that we shall use 540. So you paste this there, so it's 540. Then this takes a pointer to the header, so and rx header, and then lastly where we want to store the data is tx. I want to store the data in rx data. So then from there, maybe we can build our code to see whether we have any errors so far. So far no errors. So lastly, we want to test this data so that we can now control the LED now. If rx data, if the data that we have received is equals to 0 or 1, then it is equals. We want to turn on our green LED, so GPIO right pin, then GPIO A, GPIO pin 5, and then GPIO pin set. Then if the data, that is RX data, is equals to 2, then we want to turn it off. Yeah, so we are going to reset. Then from there can build the code and see whether you have any errors so far. So it's green. Then I'll go and open the interrupt file, and this is where we want to send the message. So if we press now, if Hal GPIO read pin, that is GPIO C or GPIO pin 13 is equals to 0, we want to send the message to the other board. So this is for sending the message to the other board, and this function is for receiving the message from the other board. So to send the message, so we have this function also in the code.C, and the function is add text message. So add TX message, sorry, and we are going to copy paste it here, and then takes the pointer to the handle, so can1, then we are going to send the message. So this is for sending, so we are using TX header, and then we want to send the data in TX data. So okay, it is not defined here, so we go back to the main function and copy all these variables, and then come and paste it here in the .interrupt file, and declare them, all of them, as extern, because they are declared in the main. So then after that we go back to our function, so TX data, this is TX data, and then the mailbox, there is a pointer to the mailbox, so add ampersand, so sorry, the mailbox is TX mailbox. Okay, there we are. So here's a pointer, and then we build our code again. And since we are using interrupt mode, we have to use this function to activate notifications, so that we can know when an interrupt is fired in the RX54. So we are going to call this function in the main, under user code begin to. So this guy takes the can type def handle, so it is using can1 and can1. Then from there we want to monitor which interrupts. So if I come here and check indication which indicates which interrupts will be enabled, the parameter may be of the combination of these. So I'm going to search for this here, and you'll see that we have all of these. So but I'm going only to monitor the can it rx54 message pending. So that, or maybe I can even monitor 541. So I'm going to copy this and have one here, and then build. So since the TX data should play around 1 to 2, go back to the interrupt, and every time I press, I have to increase the TX data so that it can get to 2, 0 plus plus, and maybe say that if TX data is equals to 3, we are going to reset to make it 0, so it shall keep switching from 1 to 2. So is equals to 0, and then now let's build the code and also finally cross check if we have any error. So for this we should only have one equal sign, so this TX. Then from there I go back to the main, check whether everything is okay. Yes, all right. It is okay. It is okay. Configure the filter, then start there, and so let's build the code finally. And now let's flash the code to one board first, and then you remove that board and also plug in the other board, because having two devices connected, KEIL may be confused. And then let's see. So after flashing the code to our board, you find that this LED is connected to this board, and this LED is connected to this board. They are just sharing a ground. So I'm going to manually set the two boards, and then from there I expect that when I press this, we should have a text to this to 1. Then this will test whether it is 1. If it is 1, it should turn on this LED, and when I press it again, it should turn off. Then if I press this, it should turn this on, and when I press it again, it should turn that off. So I'm hoping that everything is okay. So let's go. So you find that when I press, it is on, then I press again, it is 0. Okay, that is 3. When I press it again, it is on, then off. Then let's see when I press this, then again, so on, off, on, off. So there's a problem with this button, so then I press this, on, off. So that is how you can transmit data. Maybe I can view one device in the watch window, so I'm going to remove this device, and then fire the debug session. And then from there I want to add Rx. I want to add Rx to the watch window. So going to add to the watch 1 so that we can see whether data will be transmitted. And again, where we have our interrupt, when we receive a message, I want to add a breaking point. So I'm going to add a breaking point here, and then run the code. Then I'm going to insert the other board that I had removed, and then from there, when I press, you can see that we are debugging this one. So when I press this button, you should see that the code will stop at the RX54. So let's start. So I'm going to, okay, let's manually reset and press. So you can see that the code is run until here. So when I continue, you will see that the received data is the data that we sent, which is 0. Then from there, I'm going to press it again. Then it is back here. Then you're going to continue. In this case, it is now 1, and that is why you have this green LED on this board on. Then I'm going to press it again, so you can see it is back here. And then when I continue, it is 2, and then when I press it for the third time, it is there, and when I continue, it should be 0. So it will keep moving around 0 1 0 0 1 2 0 1 2, and that is how you can send data through Canvas. So maybe if we want to send more data, if we want to send like 5 bytes of data, I'll just come here, and then I will increase this to 5 and have this to 5. Then from there, I'll go to the TX header and then tell that the data length is 5. Then from there, we should not even think about the LEDs. So we just want to send data. So I'm going to initialize the data here. So I'm going to copy this, and this is code begin 1. I'm going to have 5 datas. Starting from index 0, 1, 2, 3, 4. And then I'll have this as 0, 1, and then I have the rest as 2, 3, or maybe I can mix this to be 7, maybe this to be 6, this to be 9, and this to be 5. So let's now build the code. So this is the data we are going now to send, and we shall view it when it is received by the other board. So this is 1 2 3 4 5. So then let's fly flash this to the board, to one board, and then remove that board and plug in the other board, and then load it here. Then I'm going to fire a debugging session for that. And now you can see that we have 5 data. Then I'm going to plug in the other board, and now we are going to start, and I'll manually reset the 2 boards, and then from there I'm going to press this. You can see that there is a message that is received, and then you're going to continue. So you can see the data, all the data that we sent here is the same as what is here from 0 to 4. Then when I press it again, goes off, and I press it again, goes on, off, on. Then when I do the same, so the other board will behave exactly the same. So thank you guys for following up with me. Researching on CAN bus was not easy, so I'm happy to help you. I learned it the hard way. So if you have any question, kindly leave it in the comment section, and I'll see you in the next tutorial. And also don't forget to subscribe, like, or even share. Bye.